Simon here from HarveyMudd CS5X MOOCs, and today we're going to be talking about for loops. So far, the way we've stepped through the same logical flow for some number of times is using recursion, as you know by now. But recursion can be a little hard to think of, as we've all experienced. Many times, it's hard to think of how to write something recursively, and it's not always the best way to solve a problem. We also have list comprehensions, but those are only useful when we're working with lists. There is something, however, that looks very similar to list comprehensions that we can use to go through something several times in the same logical flow. And those are for loops. Let's take a look at how we write a for loop.
Here's the syntax we use for for loops. The indentation in Python with for loops is the same as the one you've learned using if statements. Within the for loop, I will take on the first value for L. Run through the code written inside the for loop, and then iterate to take on the next value in I. Thus, the code above prints out Using what I've just shown, why don't you try to translate the recursive code for fac of n using for loops? Here's the recursive version of fac of n in case you've forgotten. I'll give you a hint. Use the range function. This is what we got. What we've done is simply iterated I through every number in the list of 1, 2, 3, all the way to n, and multiplied them all together to find n factorial. We can see that recursive fac and for loop of fac will give us the same answer if we run both of them. Let's try finding the factorial of 4 with each function. Recursive fac returns 24 as expected. As does the for loop fac. Let's try this again with another old recursive function we've written before, the power function. This is what the recursive version of power looked like. Here's what we got. Note that if p is negative, we divide 1.0 by answer rather than just 1, because raising a base to a negative power can be a decimal even if the base itself is an integer. You might have written this a little differently than us, but make sure that your solution takes into account negative values for p. Again, the for loop iterates through each value of 1 to p, and then multiplies answer by the base. Let's compare how recursive power and for loop power work for the same inputs. For example, using recursive power, if we raise 2 to the third, we expect 8. And if we use the for loop, we still expect 8. Now let's try it for a negative power. If we raise 4 to the negative second power, we should expect 0.625. And if we do the same thing with for loop, we expect the same answer. Great! They both worked. In conclusion, for loops are a flexible way to do things more than once. Don't forget the syntax. You write your for loop. You define the variable that will take on every value in the list. Then you insert the body code of your for loop, and after your indentation is done, you write the code that should go after the for loop. Get ready to start using for loops. I promise you're going to love them.